Thank you, everybody, for joining us today for the final session in our 2026 Northeast Extension Fruit Consortium's Winter Webinar Series. Today, we have Manuel Diaz-Gonzalez joining us to discuss drought in the orchard.
So no water, no fruit. So I'm glad to have Manuel Diaz-Gonzalez here with us today. Manuel is a licensed professional engineer with 16 years of NRCS and agricultural water resources engineering experience across the Northeast U.S., Rocky Mountain states, Northwest regions. He now works as a senior engineer with American Farmland Trust, specializing in irrigation systems, drainage, flood mitigation, and other resilient farm infrastructure. And with that, I'll turn it over to Manuel.
Hello. Upon Glenn's request, I'm going to start by saying that if something I learned on my career as an irrigation engineer is that people don't understand water, including myself. There is a deep misunderstanding of how water resources work, and especially how water moves in soils, and I have dedicated my career to this. And I'm going to share the little I know with you today in this practical drought management for fruit growers webinar, where I will talk about soil moisture concepts, viable water sources, and the not viable ones too, about soil moisture sensors and automation, about irrigation scheduling and farm water budget, and about funding and resources. I am Manuel Diaz. I spent 16 years with NRCS and 18 years total as working with irrigation so far. I am now a consultant in the Northeast, licensed engineer in New Jersey, Connecticut, Rhode Island, Massachusetts, Vermont, and Maine. I am passionate about my work. I love irrigation, and I love to help farmers. I cannot see myself doing another job that is not working with farmers. I would love to visit you on your farm and learn about your operation and be able to help you. And that's one of my favorite pictures from when I was working with NRCS, helping a farmer with a pump on a well. Jeremy asked if we're still in a drought. And that was a great introduction, Jeremy. Thank you for that. So this image is the soil moisture percentiles for the Northeast. It was taken yesterday. If your farm looks in blue, you're good, and the soil moisture is where it needs to be. If your area does not look in blue, you should think about irrigation already. Why is that? By now, under normal soil moisture conditions, we should all be in blue, based on the typical historical trends. But in recent years, we're getting more in recent years, we're getting pretty much the same amount of precipitation, but in stronger events and less often. And that's where often talking about drought, even when the annual precipitation seems to be the same year after year. So if your farm looks in gray, yellow, orange, or red, you're likely already in a soil moisture deficit. And if you had a crop today, you needed to be irrigating. As drought frequency in the Northeast is increasing, and my own definition of drought for the Northeast is if it doesn't rain in 1 week. If it doesn't rain in 1 week, you need to irrigate, or you should be thinking about irrigation. For most farmers, in their reality, is 3 weeks, and I get it. It's not irrigation for farmers, it's irritation. I know it's irritating to deal with the irrigation system, with the pumps, with what breaks, what doesn't break, and whatnot. But the reality is that keeping soil moisture high is the best way to fight a drought, and irrigating as often as possible is the best way. I'm sorry, not as often, but as early as possible or as practical. Once soil moisture starts being depleted, is the best way to plan for a drought. As you all know, water stress at the wrong time can permanently reduce yield, fruit size, and quantity. And planning, proactive planning, is what separates the growers who adapt from those who react under emergency. The reality of my job in the last 10 years in the Northeast have been that almost 100% of farmers react under emergency conditions. Very seldomly, I can count it with one hand, the farmers that I have met that actually purposely irrigate early enough for in case there is a drought. And again, I get it. If you most likely you are a farmer that don't irrigate unless you have to, and that is okay. That is a totally valid plan. But I hope that after today's presentation, you at least reconsider your irrigation water management plan, and then maybe even seek help from professionals like Extension Service, NRCS, or private consultants like myself. So this is a AI generated image I just created yesterday, where I want to show you the ideal conditions for a soil. Most often when I visit a farm in the summer, the soil is too dry. They just haven't irrigated because they didn't felt that they needed to irrigate because they're basing it in their opinion, not in actual data. The farmers that are irrigating based on data from like soil moisture or weather, typically they have the soils within the ideal conditions, within some range. Very few farmers over irrigate in my experience in the Northeast, although in other places of America, I've seen heavy over irrigation, so that will be slightly wet. And then the waterlog. Now, we live in the Northeast, and we can have monsoon season and drought in the same year. So if a few years ago, I remember I play softball a lot, and I remember like the summer being all cancel games, and then in the fall we just played every game. So because there was no rainouts. So I understand that water clogging can also happen, not just for irrigation, but in New England mostly because of just too much rain. Which we can have another webinar in the future about drainage, by the way. The ideal conditions is to maintain water, soil moisture between field capacity, that's not too wet and not too dry, and the management allowable depletion. And those are fancy names for something I will be explaining to you pretty soon. When stress hurts the most in orchards? When the trees are young, and it's critical when at cell division, water stress and permanent cell count reduction results in smaller fruits, and smaller fruits typically cost less money. And that's why I always tell farmers that soil moisture is money in the bank. And you will hear me say that pretty often, and I can see Jeremy from here chuckling about me saying money in the bank because I say it all the time to many customers. If you are able to keep soil moisture adequate conditions, you will be heavily improving the chances of getting the fruit that you're looking for, the desired fruit that you're looking for. And the next few slides, I will be going over why. Another high point in the orchard world is high risk point is the bloom period. Not as important, but sensitive is rapid fruit growth. And then the safe windows for not necessarily irrigating, but being careful is post-harvest. So basically, from flowering to when the fruit is picked, you need to be paying attention to soil moisture. Or you don't need to, but you should. I really like this image about the fundamentals of soil moisture in relation to soil conditions and growth factors. If you don't have adequate soil moisture, but you have good nutrients in your soil, it most likely the crop, the tree or the plant will not be taking those nutrients at the rate that it should, because no matter the availability of those nutrients, if one of them, especially water, is lacking, it will hinder the intake of the other nutrients. So if that's another reason for you to irrigate, or at least make an effort to have the soil moisture at adequate levels and increase the fruit size, or arrive to a fruit size that you desire. Drought reduces transpiration, reduces the excess in transpiration, reduce calcium transport, which then induces the deficiency in fruit even when soil calcium is at normal levels. This is particularly important in sandy and coarse soils, which is where I very often see orchards. At least in Massachusetts, almost every soil is a sandy loam, and that extrapolate too often to New Hampshire. I know in Vermont and Maine, there are some clay soils, but if you're in a sandy soil, you have to be particularly careful about the calcium intake in relation to soil moisture. And why? Because you don't want to have fruits that look like that. I am not a botanist or a specialist in fruits. I'm a specialist in how water moves in soils and how water is uptake through the plants. But I got informed about this, and we just want to maintain 60 to 80% water content for early fruit development to avoid the calcium disorders that can affect your production and that are definitely undesirable. So about young trees. When I came to New England in 2016, was during a drought, by the way, and I was actually pretty much brought to New England, coming here was somewhat accelerated because of the drought of 2016. Yeah, 2016. And people will tell me, well, I don't have to irrigate my orchard. Well, I've seen people change their opinions. Those same farmers change their opinions as I came and as I revisit with them throughout the years. In my opinion, small and young trees really need to be irrigated. The root system is not developed to uptake the water at the depth that a grown tree is. And the likelihood of mortality on that young tree is significantly higher when you do not have an irrigation system. So to protect your investment and to have a uniform crop in the future, you should definitely irrigate young trees. Mature trees are larger and they have a much more robust root system, and they have greater capacity to uptake water from deeper conditions. And that's why you see mature trees that are not irrigated. That is talking about the old style where the trees were planted, I don't know, 10, 20 feet apart. Now you have your crops in trellises or in spacing that is significantly closer than those historical and natural for the whatever tree or plant you are growing. You must seriously consider irrigation. So to talk irrigation, we must understand soil water content. What is too dry? What is too wet? What is normal or adequate, I meant to say, for your crop, in your case, orchards. And for orchards, I always assume apples because it's what for design purposes, because I cannot design for everything unless, specific for a farm, but I always have apples in my mind, or for trees, and then blueberries for bushes. So soil moisture content is dependent on soil texture. The sandy side have a lower soil moisture content, so you have to irrigate less water more often. The heavier side, the heavier soils approaching clay and loams have higher soil moisture content, so they can hold more water, and you can irrigate more water less often. Materially, they both need the same amount of water. The sandiest soil for the same crop, I meant to say, for a fully grown orchard in a sandy soil, you would need to irrigate exactly the same amount of water in terms of total volume than you would for the same orchard on a heavy soil, in a clay soil. It's just that for the sandy soil, you would irrigate less water more often, And for the heavier soil, you irrigate more water more often. But if you're irrigating 1 inch per week, you will still need to irrigate 1 inch per week regardless. And you'll have to be careful on how you do it. Well, something key to understand is the field capacity and the permanent wilting point. The permanent wilting point, I'm going to start from the bottom, is the point where your crop is about to die because it doesn't have water. And if you reach that point in the summer, you will be in trouble. And in later slides, I will show you how to determine that using instruments. You always want your crop to stay within the available water or within the allowable water capacity of the soil, which is between the wilting point and the permanent wilting point. I'm sorry, between field capacity and the permanent wilting point. Now, we do not want to even get close to the permanent wilting point. So we would typically, in orchards, we want to assume that about half of it is about half of the way between field capacity and permanent wilting point is where we want our soil to be. And guess what? That is about 1 inch for most soils, at least for most soils in New England. If you're in the really sandy side, it will be a little bit less. If you're in the really clay soil, it'll be a little bit more. But 1 inch per week, or 1 inch of water total, basically, is very close to what you want to be managing for ideal conditions within soil moisture. What I most often see is that people don't irrigate hoping for rain, and they still holding in the irrigation event hoping for rain, and they let the soil go back past the permanent wilting point, and they're in big trouble, and they often lose their crops. That is mostly applies for the veggie operations, but I also seen crops being lost in the orchard setting due to lack of water. Soil holds a lot of water, but most of it is not available to the plants. Please get that in your mind. The fact that it rained 3 inches yesterday doesn't mean that your soil have 3 inches available. Most likely still have only 1 inch of water available to it. The other 2 inches most likely went to runoff. It went to deep percolation. It is saturated now, and it will eventually go into deep percolation, but it's just not available. With some variance, of course. So, talking about an orchard, ideally we want an irrigation event about a week, dripping about 1 inch. That'll be ideal. Guess what? That doesn't happen anymore. Evapotranspiration, which is the response of the crop to the energy in the system, how hot it is, what is the relative humidity, what is the maximum and minimum temperature, what is the dew point, affect the energy of the system and how much water your crop is losing, along with the stage of the crop. For now, we'll focus on young trees or young crops and fully grown. The evapotranspiration of young crops or young trees is a lot lower than that of grown trees because their canopy is a lot smaller for young trees. But I want you to understand that evapotranspiration has everything to do with the energy of the system and nothing to do with the soils or with the crop. The crop evapotranspiration is something else, but the evapotranspiration in general has everything to do with the energy of the system, how hot it is, and other concepts. When you get like 3 inches in a day, a lot of it goes into ponding and potential, especially when you get in the hour, like 3 inches in 1 hour or something like that. Most of it that goes into runoff, and you should assume that that is just not, that most of the water is not just being available. Some ponding also occur, and when ponding occurs, you should assume that that ponding will eventually turn into gravitational water and will just go into deep percolation and not be available for the crop. We have infiltration, which what we're looking for. We do not want runoff, and we just want steady, slow infiltration that replenish our soil water holding capacity. We want to imagine our soil water holding capacity that is within the biggest part of the mass of your root zone, or down to the bottom of the root zone depending on how you want to manage it and your soil conditions. Sometimes, actually very often in New England, we have hardpan, and often even adult trees are not able to go through that. Sometimes they do. But it is up to you to understand the independent conditions of your field to determine if you want, how deep you want to manage soil moisture. The maximum allowable depletion, we have discussed that. I'm going to keep hammering on that on a few more slides, is how deep you want to let your soil moisture being depleted. And if you don't have any other numbers or other ideas, don't let it deplete more than 1 inch. And 1 inch is about 1 week of evapotranspiration on a fully grown orchard crop over the hottest part of the summer. I'm going to say that again. 1 inch of irrigation or 1 inch of soil moisture content is about 1 week of a hot summer time without precipitation. And you should be thinking of replenishing that with irrigation. We can have lateral water flow if the soil is saturated. If you apply too much water and the surrounding areas are dry, capillarity will take effect and will move water in the directions that we don't want them to go. So you do not want to over irrigate, particularly in orchards where we are irrigating with drip irrigation, most likely, and you're applying water around the tree. You want to water that tree zone, but you don't want to extend too far into the row. Although you do need to extend into the row, but not all the way to the other tree most often, depending on spacing and other conditions. But the point is that you want that water to stay within the root zone, and you want to irrigate deep and wide enough to encourage root development, but not to irrigate wide and deep, too wide and too deep that you are passing the reach of those root system. Excuse me. Unavailable water is that is beyond the root zone, and you should assume it just doesn't exist. And deep percolation is what you want to avoid the most when you are irrigating. You do not want to irrigate past the root zone vertically. So the concepts of irrigation water management, or I'm sorry, of soil moisture monitoring and soil moisture-based irrigation schedule, you need to understand your soil texture. Are you in a fine sandy loam? Are you in a sandy loam? Are you in a loamy clay loam, in a clay loam? What kind of soil is your orchard? And soil and geology is a funny thing. They play tricks on us. So you can have a soil in one part of your field and another soil in the other part of your field. And farmers talk about it as this soil is just too dry here, or that soil is just too wet on the other side. That side does not need as much irrigation because that's a wet side. This side needs more irrigation. Most likely what's happening is that the side that the farmer is talking to me or talking to someone that needs more irrigation is because I'm calling it the dry side, is because it's a sandy soil. And it has a low water retention capacity. And what the farmer often is talking about, the wet side, is a heavier soil with a higher retention capacity. Now remember that both of those soils need the same amount of water to thrive, for crops to thrive in them. It's just that how water is applied and the retention of those soils are very different. Then the next thing that we need to understand is the management depth. In New England, I have always assumed 24 inches because it's a beautiful number, 2 feet, and easy to multiply and divide for. And because very often we find hardpan past 24 inches, although that may not be the case everywhere, of course. Like here where I am in Amherst in Massachusetts, in the Connecticut River Valley, there are really deep soils, but I cannot think of very many orchards in those soils. At least around me, the orchards that I can think of are in uphill where there's glacial till, and it is somewhere between 18 and 24 inches, sometimes a little deeper. Often root mass can penetrate that hard pen and gather moisture from those deeper conditions, but the natural moisture content and the moisture retention, the available moisture, I meant to say, on hardpan is much lower than in the upper zone, like the upper soil. So as an engineer, I tend to disregard that soil moisture, although it can be beneficial for the trees to survive. Then the next thing, once you identify those two things, you need to identify what is the 50% maximal allowable depletion that I want to work with, which I have told you that most often is close to 1 inch. And I have other slides that will further enter into that concept. And then monitor soil moisture changes. That is a big lack. I've been hammering these in New England for the last 10 years. I had some early adopters. I have now some leaders that are, my customers, that are following through. And I can see soon the rest of the population, of the farming population, following suit and trying a sensor and start using data, particularly as funding funding becomes available from government sources and others to pay for those. I mean to say, I see more people trying it, and I see more people trying automation too. So monitor soil moisture. The soil moisture, as I see it, is the dipstick of your oil, or your whatever, the gas gauge. If you can see where you are, instead of just guessing where I am in my 1 inch of soil, of water in the soil, instead of guessing, you have a meter, a way to actually account for what is in there and then trigger irrigation events accordingly. Depending on if you have one or if you heard of one, most likely is a tensiometer that measures in kilopascals, and they are measuring suction. I'll explain that further later. But you can hear farmers saying, yeah, I irrigate when it reaches 25. That is 25 kilopascals, and that is a good number to irrigate. You should not be irrigating when you're at 12, and if you're at 50, you should have irrigated like last week. Yeah, and then definitely, I just said it, you start irrigation event once the soil moisture have reached the determined conditions. Now, if you have a soil moisture sensor, it takes away that incognito, that unknown, because if you have a tensiometer, once you start reaching about 20 on the tensiometer, you need to irrigate. And if you have a volumetric measuring system that give you a percentage, it's easy. Once you start reaching 50% soil moisture, you need to irrigate. And then you need to stop irrigating once you reach field capacity, which with tensiometers is typically about 8 or 10, and with volumetric is either 80% or 20%, depending on what you're measuring. Here's where I wanted to get to. Those of you who have the famous aerometers or the gypsum blocks, you have seen something like this, some table like this that have the numbers of the kilopascals that you are measuring, 0 to 200. Hopefully, I've never seen anything more than 80 probably. But you have seen what is saturated, what is adequate water according to soil moisture. I want to, let me just try to move this to this side. Okay. So I want to relate that to how much water is actually, what is the actual water content of your soil? So you have an idea, or if you haven't tried a sensor yet, so when you do try a sensor, you have a good feeling of what is there. If your sensor, if it's one of those gypsum blocks, and is reading less than 10, your soil is saturated. It is most likely at field capacity or higher than field capacity, and you are several days, if not 2 weeks, away from irrigating. And that for sandy soils is just 25 to 35 available soil moisture or water content, just because the sand doesn't hold any water. And then for sandy loams, it's just 30 to 40% water content. So you can tell that just those soils just don't hold a lot of water. Now, If you take a reading and you're between 10 and 20 in most soils around New England, like sandy to sandy, even clay soils, you're good and you don't have to irrigate. And that for loam soils is about 28%, give it or take, water content. And for sandy loam and others is 18 to 31% moisture content. So we're still pretty low in the total. Well, that's what it is. The soil just doesn't hold. It doesn't get to 100% water, not volumetrically. Now if you have a volumetric sensor, is measuring 100% because it's 100% of the potential water available in that soil. So if you have a volumetric volumetric soil sensor and you're measuring 80%, means that there is 80% of total water in that soil. Some of them measure the opposite, measure how dry it is, and it says that basically that there's 20% to be filled up instead. Moving on. Again, if you are within 0 to 10, you're too wet and you should not be thinking of irrigation. If you are reading on your tensiometer 10 to 20, you're good. If you are measuring with your tensiometer 20 to 30, you should irrigate. And if you're measuring 30 to 50, you should have irrigated 33 to 7 days ago. And anything like that, you're in trouble if your soil tensiometer is reading more than 50 kilopascals. So, but what is all this? What is all this about how they look, how these sensors look, and how do I install them and all that stuff? So let me spend a few minutes going over how they look, what they are, and how they're installed. Let's start with the most fancy one, and the kind that I like the most and the least common because it's more expensive and more fancy and require more newer technology, for lack of a better term, although this technology has been out since before I was born. So we have the time domain reflectometry, which is basically is highly accurate, and it is able to collect data very, very often, like very likely by default, it collects data like every 15 seconds. And with it collects not just soil moisture, but it also tends to collect not just real-time moisture, but also temperature and electric conductivity of your soil. So these ones are also really good for if you fertigate, to see how effective your fertigation is, and you can relate your fertigation to electric conductivity. You may be looking into one of the systems. Again, the drawback is that is more expensive. For instance, the average cost for the individual sensor unit that you will install in the soil is between $80 to $100, so $300, $400 per unit. So just 3 units in one section of soil may cost you $240 to $1,000 to $1,500, $1,400, $1,200. I'm not sure. So, and then the portable handheld, if you're going to use a handheld, is like $1,700. And if you have a stationary data logger that makes sense for multiple stations, you're probably talking about $1,000 each, if not more. And depending on your orchard and your operation, you're talking about $1,800 to $3,500 per monitoring station. And a monitoring station could be mean many different things according to the individual product. But how I see it, a monitoring station is probably just one contiguous area. There are some of these systems that cover like half a mile radius. So some of them are pretty sophisticated and cover a lot, and those tend to be at the lower side per the unit cost. The very important is that this kind measures volumetric. So the number that you're seeing is the actual percentage of available or total soil moisture that is in the soil, and you can relate that to available soil moisture. The capacitance systems are very similar in setting and cost. They tend to provide information, the commercial available ones, like every hour, real-time soil moisture like every hour, sometimes every 15 minutes, depending on the conditions. But they are also typically used in a higher tier of automation that goes beyond just measuring soil moisture. Then the most common ones are the tensiometers, the ones that I was talking to you earlier, which can be, most often farmers measure the actual soil moisture just walking to the tensiometer, to the gypsum block, and connecting the soil moisture meter with alligator clamps to the sensor and then getting a reading. Those are very popular because they're economical. They have been, the actual gypsum block have been around for a very long time. And I could think of many of the major irrigation monitoring and automation companies just use them, have adopted the Irrometer gypsum block as their product. They are good, they're effective, they're efficient, but they do not measure soil moisture directly. They measure soil tension. They measure the suction that is in the soil. A soil that is really wet have very little suction. There's no capillary forces there because it's all full. As they start drying up, there's tension start building, suction start building in the pores of the soil and the void spaces, and that's what it's actually measuring. Individual sensors, individual tensiometer sensors are fairly inexpensive, $50 to $150. The data logger, depending on which one you're getting, is even less than $500, but I would say $500 to $1,800 for a really fancy one. So a typical orchard installation of 3 sensors, 3 stations and data logger could cost $430 to even $2,500 with an automated system. How to install the sensors? In an orchard, I strongly recommend installing 3 sensors. A shallow sensor that is in about 8 inches, a mid sensor that is about 16 inches, and a deep sensor that is about 24 inches. That is most likely the most common, I would say, or at least in my mind, the depth of water that you want to be managing. And so that shallow one between 6 and 12 inches, with 8 inches being a good average, is for you to manage the upper side of the allowable management depletion, or the soil water management zone. Then the second one, 12 to 24 inches, with 16 inches being a really good average number. You will be managing the middle part, and that will most likely be your number 1 number that you want to be paying attention to. And then you also want to manage the deep part of that, because you want, especially when you want to be managing irrigation deep, especially if you are, well, regardless of the soil, you want to irrigate, and there is better bang for your buck if you irrigate deep, in terms of energy use and efficiency, coming back to the field, and other criteria. So it is important to install a deeper soil moisture sensor. I say that because most often I only see 2, and they're fairly shallow, maybe 8 and 12 or 8 and 24 inches. I'm sorry, 8 and 16 inches. Install them in representative rows. Install them where you irrigate. Install them between emitters and between trees and between emitters. Don't install them on the row where they may be mowed or something else. Avoid field edges and avoid low spots to be able to gather representative data. If you're in a hilly place, install them upland and upslope and downslope. That way you can see how irrigation is changing across those conditions. And take note of the restrictive soil layers, I have already talked about hardpan, and there may be others in other areas that I have not worked on. So that's enough of soil moisture and soil moisture monitoring. I want to move on to water sources and the practical sense of all this. I'm going to go through this pretty quickly. This is fairly common information, but I'm going to go over it nonetheless because it's important. But if you need to remember two things about soil moisture and drought, number one, remember that the key is to be prepared for a drought, and to be prepared for a drought is to get to the drought already having adequate soil moisture content and not wait for the drought to bring up that soil moisture content. And number two, soil moisture is money in the bank. If you have adequate soil moisture, you're giving your crop a much better chance to thrive. Water sources, municipal water. Not everyone have it, but I love it. Some people think it's expensive. As an engineer, I do not think it's expensive because it's clean and it's always there. I do not think it should be used because ethically, I do not see why we should be using a treated source for irrigation. But the farmers that I know that use it love it, and because it's convenient. And the farmers that use it because they have to. Rivers, if you have a river, you're lucky, and you likely have a large amount of irrigation water. Ponds, I believe that ponds are available, but underused alternative. For some reason, people always want another well, and unfortunately, they're thinking of a bedrock well. And most bedrock wells, almost every bedrock well, almost every bedrock well is not a viable source for irrigation because they just don't yield enough. In the average bedrock well in New England produces less than 7 gallons per minute, which is infamous. It's nothing for a commercial agricultural production. Now, ponds, particularly if installed away from wetlands, are viable, are something is costly, just like a well, I would say, but you do not need permitting in most places, I think, and you can hold a lot of water, and you can test. You can have an expert like from the NRCS or from other entities, or an expert like myself be present when a dog when a hole with a pit is dug to test for water conditions, and data can be gathered then to determine or to model how big a pond would need to be to hold the water needed to get you through the irrigation season. I do not put too many ponds because they're just not popular, but I cannot strike enough that a pond should be strongly considered as an alternative before a deep well, before a bedrock well, because there is far more likely that a bedrock well will get you 0 gallons a minute than it will get you 100 gallons a minute. That's statistically across the Northeast. Gravel wells. Gravel wells are wells that are on aquifers, on gravel aquifers. Like here in the valley, there are many of those. And in New Hampshire, along the Merrimack River, you can find those. And I've seen them in upland too. Gravel wells are the best if you have the right conditions. But for you to know if you have the right conditions, you need an expert. You need an expert like a geologist or an engineer who does this kind of work, like myself, to really guide you towards that, because very often I see people who have the conditions to install a high yield gravel well, and they just call the well driller. They do not know. They just tell them, I want a well, and they end up with a bedrock well. And what the bedrock well did was to drill through the good gravel in the water to bedrock to find no water. And at the end of the presentation, I have a really good story about this one. Dog wells almost never are a viable option, although I have installed a few dog wells that produce a ton of water and were definitely a viable option. So how much water do you need? If you have a typical 7 gallon a minute well, you can irrigate about 1 acre with that, with heavy monitoring and heavy automation. That's about it. Well, or that can be extrapolated to many acres. If you have 10 acres and 70 gallons a minute, which is 7 gallons a minute per acre, you can irrigate that, but you will need to implement a serious irrigation water management plan with full automation and monitoring to be able to really pull that off. Otherwise, if you just want to irrigate like 3 hours a day and that's it, like many farmers do, then you need like 30 gallons per minute per acre for the drip irrigation. And that translates to about 1.5 horsepower per 30 gallons per minute for you to irrigate with drip. If you have, if you have 10 acres, you'll need 300 gallons a minute and a 15 horsepower pump, basically, give or take. These are very rule of thumb numbers. You will need a fully engineered system to be able to really make sure that that's how it works. Excuse me. For sprinklers and frost protection, you need like 60 gallons a minute and about 3 horsepower per 60 gallons a minute per acre to make that work. So long story short, you need a lot of water to irrigate. And you cannot believe the calls I have gotten through my career of customers telling me, yeah, I have this 17-acre field and I want to irrigate with this well that produces 9.5 gallons per minute. And I'm like, no, that will not work. And they insist that they can do it. And I can only provide the facts and the engineering for it. I want to go to ponds because I really want people to take it serious. Not that I think they're best or environmentally or anything else, but people do not evaluate that option enough. They do not check that box that I evaluated that enough. There are places where ponds are granted, where the groundwater-fed ponds away from wetlands can be possible. There are places, many places, where building an irrigation pond, even if it's just for runoff, winter runoff, is the only viable option because bedrock wells do not yield. There are plenty of places where glacial till yield enough water to feed a pond, but not to feed a dog well, for instance. And sometimes going through the permitting process of installing a pond near wetlands, and depending on state regulation and how it's interpreted and this and that, and sometimes even Army Corps and whatnot, is really the only way to go if you really want water. But consider a pond over a bedrock well and consider trying it away from wetlands so you don't have to deal with permitting, even if you lose land. Often farmers have the mentality that they want to crop every square inch of their farm, and putting a big pond will just be losing money. How I see it is a pond is an investment that will help you save crops in the future and actually stabilize your income. Drip irrigation. Typical orchard scale irrigation for drip is $800 to $2,000 per acre, depending on what drip tubing you're using, how many drip tubing per row you're installing. So the full installation is about $1,800 to $4,000 per acre. Some complex projects require more like $6,200 to $200 per acre for installation. And yeah, I'm not going to go a lot over it because you can just call your vendor and they will tell you how much it will cost according to the needs and the products that are available in the market. I do want to go over real quick about the water, the parts, particularly filtration, which is something often overlooked. So, of course, you need the water source and you need that to be robust enough based on the numbers that I gave you. And you need a pump to pressurize that water, most likely. But you will need a filtration system, and you need the right filtration system for operation. You have to be thinking thoroughly about what system you will be using and how you're going to maintain and how you're going to clean it, how it's going to be clean and whatnot. And then you want to properly design an installed system because you want pressure uniformity across the system. So each tree is roughly getting the amount of water that you already know you're applying. You cannot believe how often I go to farms and the first trees are getting like a lot of water and the last tree on the other side is really getting nothing. And you can even visually see the difference by visual inspection across the field. You can see the difference on the hydration between trees at the beginning of the drip line and trees at the end of the drip line because that drip line was not properly designed and installed. The NRCS have funding, historically have had funding for orchard irrigation, especially if you're going with equip, if you're going from sprinklers to drip. And there are the next thing is automation. Well, that is the thing for that already happened in the market for many years. But if you're already doing well, I already have a good filtration system. I'm already doing if you're already monitoring soil, you should be considering automation as the next step. That way, as I tell my customers, you can be in Florida on vacation and you can just look at your phone and activate your pump or turn it off, or know if there's a leakage, or know if this field was irrigated or their field was not irrigated, or see if there are problems in your system, and then call one of your employees to go check it out. Of course, I make that Florida on vacation example to exaggerate, well, not exaggerate, it's a reality, but to point how convenient automation can be. Yeah. Being prepared for a drought in the Northeast is available water content. Make sure that you're heating your soil with good water early on, and that you have the soil moisture sensors to prove it. Again, soil moisture is money in the bank. Irrigate early and keep soil moisture adequate. By high, I mean closer to field capacity than the opposite. Graphically, how soil moisture looks. Early in the season, that is July 1st, but that can be May, that can be June, it doesn't matter. Early in the season, you have high soil moisture. Let's imagine that is a fine sandy loam soil. Early in the season, you have 25% total soil moisture. That's not available. That's total soil moisture, which is close to 100% available soil moisture. And it rains and it fluctuates and it rains again, and then it stops raining for several days, and the soil moisture starts going down to 10%. Then you create an irrigation event, you bring it back up towards 24, 25%, and you let it go down again. This is the kind of data that I want you to be using to trigger irrigation events, and hopefully and eventually you will have a system that automatically trigger irrigation events for you. We want to be looking for this difference in slope in our graph. Soil tends to lose water rapidly, and when you see a point of inflection, actually these farmers should have irrigated just at the end of that circle and not wait until July 22nd. Not that there's nothing wrong, but once you see that point of inflection of the difference in slope in your graph, that is the point where you need to be irrigating. And that is gained with experience and by looking at the data. And I just want to show what is irrigation set point and the field capacity for this particular project. Really quickly, and I'm almost done here. You want to irrigate 1 inch per acre per week when it doesn't rain. 1 inch is 27,000 gallons. 1 inch per acre is 27,000 gallons of water. So if you have a 40-acre field, you need 1 million gallons of water per week to irrigate. So you have to be thinking about how if you have a 40-acre field, you need to be thinking how you're going to get that kind of water. Funding. There's something called the drought declaration alert that is through the Farm Service Agency. And that is really the best. It is by county, and when they declare the county on a drought emergency, often the federal government applies funding to that, and it becomes available to farmers. So you should always be on the lookout after a drought if your county was declared a state of emergency, because FSA, in my opinion, have a really good low friction program for you to improve the water resources of your farm after a drought. Then the NRCS have funding. Sometimes states like in Massachusetts, EMDR have funding, and I highly encourage you to get help, to get a professional to help you plan for this. And Extension Service, NRCS, the private sector can help with this. I want to finish with a note. Those are Al Thorpe and Elizabeth Keene. The NRCS told them years ago to put a bedrock well. They put 800 feet bedrock well. It pretty much got them 0 gallons a minute. I show up about 6 years later and I tell them, Elizabeth, there is water right here, like 6 feet down. I see the landscape, I see the geological features. I'm like, I know there's water here. It took me about 3 years to convince them to put up a shallow gravel well. Now they have 120 gallons a minute from 2 wells that are 40 feet apart. So engineering your well is not something that people think, but if you want a high yield well, you need to be thinking about this. I'm almost running out of time. I want to tell you that I work with a team of people who provide technical services. I am the engineer, and I have a team of experts that help farmers with a wide range of practices that go from energy assessments and pest management, nutrient management, soil management, grazing management, and you name it within agriculture. I myself help farmers with everything that has to do with irrigation. But my team also helps with business crop production and grant writing, record keeping, organic planning, and whatnot. I also help with infrastructure like stream crossings, barns, and other things, that especially those that require a permit or that must be engineered. And thank you.